Hello, in this video we're going to talk about complex numbers, and these come about when we are trying to solve quadratic equations. So let's look at this first example where we're trying to solve x squared plus 36 equals 0. We would first subtract 36, and I would get x squared equals negative 36. And then when I take the square root, look what happens. I'm trying to take the square root of a negative number, and we would get an error message on our calculator. So what do we do when that happens? Well, mathematicians created an imaginary number called I, and I is equal to the square root of negative 1. All right, and they do that so we're allowed to solve these kinds of equations. So anytime that happens, we're going to substitute I in for the square root of negative 1. The other thing we have to keep in mind is what is I squared equal to? So if I take my I definition, here's our definition, and I square both sides, and I would get I squared on the left, and then what happens when I square a square root? They cancel each other out. So I have just plain old negative 1, no square root. So I squared is equal to negative 1, and we will be using that later when we start simplifying. So here's how that looks just in simple terms. So when we are solving that square root of negative 36, we would split that up into be the square root of negative 1 times the square root of positive 36. So I can replace the square root of negative 1 with I, and then I can replace the square root of 36 with the square root, which is just 6. So we would just do I times 6, and the way we write that, I'm going to write that to the left here, that's 6I. So our answer would be 6I. If I try to do the square root of negative 7, again, I'm going to pull it apart and take apart the negative 1 times the square root of 7. So the square root of negative 1, that's just I. The square root of 7 is not a perfect square, and we cannot simplify it any further, so that's just the square root of 7. So that's all I can do with that one. On this third one, I'm going to square both of these things. So I'm going to square the I, and I'm going to square the square root of 5. So when I square I, that's where the I squared comes in. I squared is equal to just plain old negative 1. If I square the square root of 5, that's just going to be 5. Remember, the square and the square root cancel. So I have negative 1 times plain old 5, and that's going to give me negative 5. So that's just so you can see how I and I squared work when we're working with different kinds of values. Now let's solve these two. So I'm going to subtract the 26 first. And I have 2x squared equals negative 36. Divide both sides by 2. So I have x squared equals negative 18. So now I'm ready to take the square root on both sides. And so I get x equals plus or minus the square root of negative 18. So I need to break up that square root of negative 18 into negative 1 and the square root of positive 18. So we know that this square root of negative 1 is I. I'm going to continue this up here, guys. So x is equal to plus or minus I square root of 18. And remember, we've already talked about how to simplify the square root of 18. We can pull these apart to be square root of 9 times the square root of 2. The square root of 9 is 3. Square root of 2 is just square root of 2. And don't forget about the I here. The I is going to come down in front here. So my final answer is going to be x equals plus or minus. I'm not going to write I times 3. I'm going to write 3I, just because we're used to writing the number in front of the letter, times the square root of 2. So that would be our final answer there. In this second one, remember with the parentheses, I want to get rid of everything that's not squared first. So I'm going to divide by that negative 3 first, and I'm going to take the square root. So I'm taking the square root to cancel out the 2 in the square root. Now I'm going to have plus or minus the square root of negative 4. I need to split up. So I have the square root of negative 1 times the square root of positive 4. So square root of negative 1 is simply I, and then the square root of 4 is simply 2. So again, I don't like to write it that way. We're going to write it like x minus 1 equals plus or minus 2I. And remember, we're still not done. We have to still get rid of the minus 1 on the left-hand side. So I have to add 1 on both sides. And because 2I is not the same, it's not like a like term with 1, I can't combine them. So don't make that 3I or anything like that. Here's how we write it. I'm going to write the plain old number first. I'm going to write the 1 first, 1, and then I'm going to do plus or minus 2I. And that's okay to leave it like that. Okay, those are our two answers. So that's solving using I and how we use I to keep going in our equations. Now let's talk about just what is I and what does that mean for us. So now that we have this new imaginary number, we have to consider where do all the other numbers that we've been learning, where do they fit in? So we have this big number system called the complex number system. And all the numbers in this system can be written like A plus B times I. And A and B are just numbers. They can be a whole number or a fraction, a decimal, anything like that. But then they have I is always with the B part. So all of the real numbers that we've learned up until imaginary numbers, all of them can be written as this complex number. So let's take the number 5. I can write that as 5 plus 0 times I, because we haven't had the imaginary part yet. Take like a fraction, 1/2. That can be written like 1/2 plus 0I. So all the numbers we've dealt with are kind of in this area, this rectangle. Now the imaginary numbers we were just talking about, let's say like our last answer, 1 plus or minus 2I. So I have 1 plus 2I and 1 minus 2I. Those are both imaginary numbers because I have both an A and a B part. Notice that I have a number in front of the I. It's not just 0. So anytime you have I in your answer, that's an imaginary number. We can get a little more specific and say it's a pure imaginary number, and that's just if I don't have that one part in the front. So for example, when we did the square root of negative 36 and we got 6I, this was what we would call a pure imaginary number because it's like I have 0 plus 6I. So that would be a pure imaginary number, but we won't write the 0. We'll usually just write 6I. And all of these labels are not necessarily important for you to memorize, but I just want you to know, where do all of the other numbers fit in with that? All of them can be written as a complex number. So what we're going to do next is we're going to make sure that we can write all of our answers in this A plus BI form, and that's considered to be standard form. So we're going to write these following expressions in standard form. So our answers have to look like A plus BI. So when we're adding or subtracting anything with i's in it, you just treat I like a variable. And with variables, we look for like terms. So in this first example, A, 8 and negative 2 are like terms because they're both constant. Notice they don't have an I with them. And then 7I and 3I would be like terms because those are the imaginary parts. So I'm going to combine 8 plus negative 2. That gives me 6. And then 7I plus 3I gives me 10I. And that's all we can do with it. And notice it looks like A plus BI. So I have A would be my 6 and B would be my 10. All right, let's do subtraction. Now with subtraction, remember that we have to distribute that subtraction or that negative sign to that parenthesis. So this is really like negative 4 minus 3i. Notice nothing here changed, but I have negative times a positive 1, that would be a negative 1, and negative times a positive 4i, that would be negative 4i. Now we're ready to combine like terms. So I have negative 4 and negative 1. Those are the constants, the real parts. So that would be negative 5. And then I have negative 3i, and negative 4i. That would be negative 7i. And notice that's an a plus bi form, so we know we're finished. In part C, we are multiplying complex numbers, and this is going to work just like FOIL or distributing. That's when we do 2 times 5, that's 10. And I'm going to do 2 times negative 2i, that would be negative 4i. Then I do 3i times 5, that would be 15i. And then 3i times negative 2i, careful here, this is going to be negative 6i squared. Remember, I times I would be I squared, just like x times x would be x squared. So I'm going to combine like terms. These two middle ones are like terms, but also keep in mind that we said I squared was equal to negative 1. So we're going to replace that with a negative 1. All right, so 10 stays here. I'm going to combine these like terms in the middle, so that would be plus 11i. And then here I'm going to have negative 6, but instead of I squared, I'm going to be writing negative 1, because that's what I squared is equal to. Notice that there's nothing in our a plus bi form that allows us to have I squared in it. So what is negative 6 times negative 1? We'll continue this up here. So I have 10 plus 11i, and then negative 6 times negative 1 would be positive 6. And now I have some more like terms I can combine. All right, so we can combine 10 and 6 to be 16, and then we have 11i. So that's our a plus bi form. All right, so a few other multiplication ones. In this example 16, I don't know why I jumped to 16, but I did. I'm going to distribute that I. So I'm going to do I times 2, that's 2i, and then I times I is I squared. Remember what we said we do with I squared. I squared is the same thing as negative 1. And then again, we want it to be like a plus bi, so I'm going to write that negative 1 first, and then plus the 2i, just so it looks like a plus bi. Now, what do we do when I have parentheses squared? Remember, that's the same thing as doing 6 minus 7i times 6 minus 7i. So I'm going to distribute, just like we've been doing. So 6 times 6 is 36. 6 times negative 7i, that's negative 42i. Then I'm going to do negative 7i times 6, that's negative 42i. And then negative 7i times negative 7i is positive 49i squared. So what do? We combine our like terms in the middle and replace the I squared. So I'm going to have 36 minus 84i plus 49 times negative 1. Remember, I replaced the I squared with negative 1. So if I recombine that, that'll be 36 minus 84i. Positive 49 times negative 1 is negative 49. So now I can combine these constants together, and that will give me a final answer of negative 6 minus 84i. So that is written in a plus bi form. Now our last examples are going to be dividing complex numbers. And when we divide complex numbers, we have this thing called a complex conjugate. All right, so complex conjugate, all that means is that you keep the number parts the same, but you're going to change the sign in between them. So for example, if I start with 3 minus 2i, the complex conjugate is equal to 3 plus 2i. So the 3 and the 2i stayed the same, but I changed the minus to a plus. So here's how we use that. We're going to write this in standard form, and in order to get this fraction out of the way, I don't want to have an I in the bottom part of the fraction, the denominator. We are going to multiply the numerator and denominator both top and bottom, by the complex conjugate. and that's of the denominator. So in my denominator is 3 minus 2i. So I'm going to multiply the top and bottom by its complex conjugate. So we already know the complex conjugate of 3 minus 2i is going to be 3 plus 2i. Okay, so all we're going to do is do that multiplication, and we've already talked about multiplication. We've done it a bunch of times now. So I'm going to be doing 2 times 3 and 2 times 2i. That'll give me 6 plus 4i in the numerator. In the denominator, I have to FOIL or distribute that out. So I'm doing 3 times 3 is 9. 3 times 2i is 6i. Then I have negative 2i times 3 is negative 6i. And then negative 2i times 2i is minus 4i squared. Okay, so now we need to simplify that. Now look, watch what happens. I can't do anything in the numerator, but in the denominator, when I combine these like terms, 6i minus 6i, those cancel, and that should happen. If that's not happening when you're doing this, you're doing something wrong. And then we want to replace the I squared with negative 1. So I'm going to have 6 plus 4i over 9 minus 4 times negative 1. So I have 6 plus 4i over, I have 9, negative 4 times negative 1 is positive 4, so I have 9 plus 4. So what I really have now in the denominator is 6 plus 4i over 13. So the whole purpose of the complex conjugate is so I do not have I in the denominator anymore, and we were successful in doing that. If you don't get a whole number in the denominator after you do that, then you did it. Then you did it wrong. Something was wrong. Either you found the wrong complex conjugate, or you multiplied incorrectly. Now, this looks like we might be done, but again, we want to write it in a plus bi form. So I need to get one number plus another number. So the way we do that is we're going to split up this fraction. Remember, this really means I have 6 divided by 13, and then I have 4i divided by 13. So I have 6 over 13 plus 4 over 13. And that's how we're able to write it in a plus bi form. So all you're doing is just splitting up that fraction into 2 separate fractions. All right, last one. Notice that in this one I have 2 i's, but when I'm doing the complex conjugate, I'm going to do the complex conjugate of the denominator, the bottom. So what's the complex conjugate of 1 plus 2i? That would be 1 minus 2i. And again, I would suggest using parentheses so you remember that you have to distribute both of those. So we're going to do 2 times 1 equals 2. 2 times negative 2i is negative 4i. Then negative 7i times 1 is negative 7i. Negative 7i times negative 2i is positive 14i squared. That's all in the numerator. Now we're going to do the denominator. So that's going to be 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1, that's positive 2i. And then 2i times negative 2i, that's negative 4i squared. All right, we're ready to combine now. In the numerator, these combine, and I replace the I squared. So that's going to become, in the numerator, 2 minus 11i plus 14 times negative 1. In my denominator, I'm going to combine the negative 2i and the positive 2i. Remember, those should cancel. And then I'm going to replace the I squared. So I should have 1 and then minus 4 times negative 1. All right, let's simplify those negative 1s. So in the numerator, I have 2 minus 11i. 14 times negative 1 is negative 14. And then in my denominator, I have negative 4 times negative 1 is positive 4. So I have 1 plus 4. So we're getting there. We're almost there. I'm going to combine my constants together. 2 and negative 14, that gives me negative 12 minus 11i. And then in my denominator, I just have 5. Okay, so we did all that work and we simplified. make sure to write it in a plus bi form. So I'm going to write negative 12 over 5. I'm writing one single fraction, and then I'm writing another fraction, 11 over 5i. So all I did was take this number over 5 and this number over 5. Okay? And this is our final answer, writing in a plus bi. We will definitely do a lot more practice in class, so make sure you have these notes.